Any equipment can fail, but sometimes the failure goes so far that even an experienced engineer hits a dead end. That's exactly the case we have here. In a neodymium laser, the key moment is a powerful pulse from the xenon pump lamp, which initiates the generation of laser radiation. The lamp is located here, but this very pulse is not being generated by this device. The device itself is not charging the high-voltage capacitors. Without this, there is no flash, no pumping, and no laser radiation. So, we switch to diagnostic mode. Let's check what signals and voltages are present here. Step by step, we will analyze the operation of the high-voltage generation unit and determine why the capacitors are not charging. So, let's begin. Right now I have such a device in for repair. It is a photoepilation unit and a neodymium laser for tattoo removal. These two handpieces are connected here. So what is the problem? There are no flashes on the tattoo removal handpiece. That is, the neodymium laser lamp ignites, but there are no flashes. Now we can turn it on and take a look. Alright, I'm powering on the device. The protective film just hasn't been removed from the display. That's why it looks stretched. The device is starting up. Alright, let's select the standard mode. Okay. Here is the handpiece. It doesn't work. This is the laser beam, basically a laser pointer. Now I'll press the standby button. There it is. A click. The contactor engaged. The lamp should ignite. You can see the lamp is lit there. And there you can see the neodymium crystal and the glowing lamp. Now we press the ready button. Alright. It should produce flashes. We can see that it counts pulses. But there are no flashes. Let's figure out what the problem might be. For now, I'll turn it off. So what do we have inside? I have already disassembled it and removed the case. These capacitors are for the photoepilation function. They are not of interest to us. These two capacitors are the ones we need. So they are being charged. When we press the button, they discharge through the ignited lamp. A flash occurs and the laser radiation is generated. Now I'm curious if there is any voltage on them. Someone has already worked here, because I can see the wires have been stripped. They probably checked the voltage on the capacitors. Well, now I will check it too, and all this goes. And all this goes. Where does it go? Into this block. It is labeled laser power. This is the capacitor charging and pulse forming unit. That's where the issue likely is. I'll continue disassembling it, but first I'll measure the voltage on the capacitors. So let's check whether there is any voltage on these capacitors at all. There can be up to 1000 volts here. My tester measures only up to 600 V. So I installed a divider by 2. Now I'll connect the tester and turn on the device. Let's see if voltage is generated there. Alright, the tester is connected. Now it shows 0 volts. Accordingly, the device is turned off. Turning it on. Still 0 volts. It will remain like this for now. Alright, 5 volts. That's very little, considering the divider installed there. That means there are only about 12 volts. Alright, switching to ready. What do we have? Yes, 5 to 6 volts. Well, there's practically no voltage on these capacitors. Okay, checking again. The lamp lit up. No flashes. Pressing the button. Laser radiation warning is active. The counter is counting pulses, but there are no flashes. Probably something is wrong with the inverter. Turning the device off. But there are no flashes. Probably something is wrong with the inverter. Turning the device off. Most likely the inverter is located here, which generates the high voltage. Now I will disassemble it and take a look. So here is the device. I removed this block. It was installed here. Now it has been removed. We will investigate it. Here it is, this block. I cleaned it from dust. The lamp is connected here, plus here, and the lamp minus here. Capacitor minus, capacitor plus. Here the mains power is connected, 220 or 230 volts. Here is the control ribbon cable for this block. Here it is without the top cover. This part is the high voltage section. From here this red wire goes to the contactor. And this section here is the inverter board. A heatsink and powerful transistors that generate voltage for charging the capacitors. From here it goes to the connector terminals where the capacitors are connected. So now we will figure out what is wrong with this block. So I analyzed this design. This is the power supply. The primary is below and the secondary is here. The primary power supply, the lower one, converts the mains voltage of 220 or 230 volts into approximately 400 volts. This voltage goes through this wire, red and black on the connector from below. Through this wire the voltage goes to the upper inverter converter, which converts it into an even higher voltage for charging the capacitors. The capacitors are charged through this connector. Through this cable it goes to these contacts. Now we need to find out which part is not working. We will start from here. I will check whether it generates voltage for the inverter. So, I continue working with this block. The situation is currently as follows. The lower primary power supply is working. It outputs approximately 350 volts. Here I measured it and brought 2 wires out here. When repairing such things you often have to remove everything from the device, disassemble it, solder wires, assemble it again and put it back in the device. And only then you can take measurements. So I carried out the measurements. This lower primary power supply works. Now I need to deal with the upper section. Whether there is a control signal on it, which comes through this bus. Whether the PWM works, or whether these transistors are not working. I will need to measure what appears on the transistor gates, but the power supply is present here. Alright, I will continue investigating. If voltage is supplied to this block, then we need to check the oscillation on the gates of these transistors. There is no typical PWM controller here. Instead, there is this control module for the inverter.
Тут модуль керування цим інвертором.
By this marking, it can be found as a power supply control module.
Модуль керування блоком живлення.
Alright, now I will check
Я перевірю, чи
whether
видає
it produces any signal to the
сигнал
transistors.
на транзисторі. Ось знову
Again, I brought out the wires.
дроти.
Now I will assemble everything and connect the
Зараз збирати
oscilloscope
і до них під'єднуватися осцилографом, дивитися їх.
to observe the pulses,
Але
although I
здається
suspect they will
мені,
not be
що
there.
їх не буде.
And if this
Якщо
module has
вийшов
failed,
ззаду оцей модуль,
that will be
буде
very
дуже
unpleasant
неприємно,
because there is
тому
no
що
documentation for it,
документації на нього немає,
and especially no circuit diagram or connection diagram.
схеми включення,
It is impossible to find
хоча б
even a basic
опису
functional
його
description.
функціоналу теж не можна знайти.
Alright, now I will check whether it works or not. I started the
Запустив я
device,
цей апарат,
checking pulses on the
перевіряю
transistor
імпульси
drivers.
на драйверах транзисторів,
The oscilloscope is connected.
під'єднав осцилограф,
Right now there is nothing.
нічого немає,
Turning it on.
вмикаю.
The contactor engaged.
Контактор
The lamp
спрацював,
ignited.
лампа запалилася.
The capacitors are not charging because there are no pulses
Немає імпульсів
on the transistor
на
gates.
транзисторі.
So, it didn't turn out to be a quick repair. So we will need to investigate everything carefully. Here is the device. I removed this block from it and connected it with these long wires. I extended the wires to figure out what signals are coming to it. There is a suspicion that this inverter module is not working, but it is basically a black box. It is unknown what signals come to it and what its algorithm is. So now we will determine what signals come from the device to this block. They go through this ribbon cable, enter here, and then go to this board. Now I will record oscillograms in different operating modes to understand how it is controlled, and then see how these signals affect this module, whether they reach it or not. Then we will make a conclusion, whether it works or not. So, we are figuring out how this block is controlled. The device is currently on. I already figured out some things, but the recording was not saved. Now I will quickly explain everything again. So, we're figuring out which commands are sent to this unit through this ribbon cable via this connector. I'll connect the oscilloscope here now. First contact. We see 12 volts on the oscilloscope. There are no markings on this board, but on the board it comes from. There are labels. I read VDD. Makes sense. Second pin. Second contact is not used. Third contact is labeled as SIM OK. Voltage appears on it when the SIM board has triggered and the lamp lights up. If the lamp lights up, the voltage here is currently in this state. I connected it, 12 volts. When the lamp turns on, it should drop to a lower level. If the lamp didn't light, the voltage stays at 12 volts, and the device understands the lamp didn't turn on. It didn't light. Now I'll turn on the lamp, and the voltage should drop. Yes, we can see on the oscilloscope that the voltage dropped. Okay, turning off the lamp. Voltage returned to its initial value. Third, fourth, that's 0. Of course, nothing there. Fifth is labeled CMD. But I found that this voltage is proportional to the energy to which the capacitors are charged. The higher the voltage at this contact, the more the inverter will charge the capacitor. It's 0 volts here now. Turn on the lamp. Lamp lights 0 volts here. When we activate the working mode, capacitor charging begins. Now, voltage at this contact is roughly 4 volts, corresponding to 500 mJ of energy. If I increase the energy, the voltage at this contact should rise. I'll do that now. Increasing energy to maximum. Maximum here. 4500, 4700, 4700, no further adjustment. Yes. We see roughly 6, 7, 8. Well, about 8 volts. Good, understood. We figured out the purpose of this contact. Next, sixth. Sixth is the signal to turn on the SIM board. To activate this high voltage board, so the lamp lights. It's also active when voltage drops. More precisely, when voltage drops. It means a command came to turn on this board. Turning on. Yes, voltage dropped. A command arrived for the high voltage board to operate. It started and the lamp lit. After the lamp lights, voltage at pin 7 also drops. Next, 7th pin. Labeled EN, enable, I assume. It has 12 volts. When we activate working mode, voltage drops. I suspect this signal commands the inverter to start. So while there is no low level at pin 7, as now, the inverter will not turn on. Next, pin 8. Labeled P out. I suspect it's pulse out. Input for pulse formation. When we press the button on the manipulator. Wait a moment, I'll take the manipulator. Press the button. So I took the manipulator, pin 8. 1, 2, 3, 4, 5, 6, 7, 8. Connected. Pressing the button, pulses should appear here, which will command the capacitor to discharge through the lamp. Pressing. Yes, pulses are present. Flashes will form according to these pulses. That's basically it. 9th, 0, GND, 10th not used. Logic of operation is fully clear. So, we can say we now have information. That will help us check the functionality of this module. Next, we'll examine the inverter unit, and specifically this module, how all these commands reach it, and what it outputs. Currently, it produces nothing at the output. Next step, we check what goes to this inverter board. Reminder, this unit consists of the SIM board and the inverter board. We've dealt with this connector, figured out which commands go to the SIM board, and some commands pass through it to the inverter board, specifically the commands related to igniting the lamp. Control this simmer module. There is sim OK, and the second command is simmer. Well, 12 volts, that's obvious.
Напруги 12 вольт це само собою.
Here.
Ось. А на цей
And this
блок
block should
вже
receive the
повинні
commands that
команди,
specifically
які керують
control the
саме
inverter
блоком
module.
інвертора.
These are
Це
the commands to
команди,
trigger the P-out pulse.
На запуск імпульсу P-out.
As it was marked for us there. Well, let's call it the pulse trigger command. Then the command to turn on this module.
Команда на увімкнення цього блоку.
And a signal proportional to the voltage on the capacitors.
Напрузі на конденсаторах. Тобто
That is, proportional to the energy stored in the capacitors. So, let's check.
Перевіряємо.
First pin, we see 12 volts on the oscilloscope.
На осцилографі бачимо 12 вольт.
That's correct.
Так повинно бути. Другий
Second
контакт.
pin, 0. Yes, that's right.
Так і
GND.
є. GND. Третій
Third
контакт.
pin. This is the
Це
pulse trigger
сигнал,
signal.
Запуску імпульс. Я
I trigger a
роблю
flash.
спалах,
Pulse.
імпульс.
Yes, it's there.
Є.
It comes through.
Приходить.
Or rather, it doesn't come, it is applied to this board.
На цю плату.
Whether it reaches there or not, we don't know yet.
Ще не знаємо, тому що
Because for now we are
поки
measuring what
виходить
comes out of this board. At least it goes to this module.
На цей блок він йде.
Next, fourth.
Так, далі, четвертий.
Command to start this
Команда
module
на
in
запуск
general.
цього блока. Взагалі.
Okay, now we'll turn everything off.
Зараз ми все вимкнемо.
Here it is inverted.
Так, тут вона інвертується. Тому
So it came to the simmer
там у нас
board,
вона приходила на цю плату, на цей плату сімера.
and the low level
По
activated the switching of this
низькому
module.
рівні активувалося увімкнення цього блоку. Тут вже
Here
вона
it is
на
inverted on the
платі
inverter
інвертується,
board
там
through an
через
operational
операційний
amplifier.
цикл,
There's
там
probably
є
another
ще
condition.
одна, умова, напевно, якась, я
I haven't examined it
конфігурація
exactly.
яка.
But
Але
if
якщо
everything
все
is
добре,
fine,
то вона
it
сюди
comes here in
приходить
non-inverted
в
form.
такому неінвертованому
So now I turn on.
Ось я вмикаю.
The simmer, it works.
Запрацював, лампа
The lamp
запалилась,
ignites.
вмикаю роботу.
I start operation. Yes, the command to turn on this module has been sent.
Увімкнення цього блоку пішла.
Good.
Добре.
Next, fifth pin.
Так, наступний вивід, п'ятий.
Fifth
П'ятий
pin.
контакт.
This is a
Це
voltage
напруга
proportional to
пропорційна
energy.
енергії.
Yes,
Так,
there is
є
some
якась
voltage.
напруга, зараз
Now
ми
we'll adjust the energy.
порегулюємо енергію.
I increase it.
Додаю. Це було
That was 500
500
mJ. I've raised it.
Підвищив.
Yes. The
Є.
voltage also
Так, напруга
increased.
також підвищилась.
Let's do
Давайте
more.
ще.
Well,
Це
that's
майже
almost maximum. I turn it on. Yes.
Так, є.
It increased further.
Підвищилось ще.
Okay,
Так, ну
now we
добре,
turn
все
everything off.
вимикаємо.
Okay, got it.
Так, зрозуміло.
These
Ці
commands go
команди
here.
сюди йдуть. Є тут
There's
ще
one
одна
more command.
команда.
On the seventh pin, there is a command. That is sent to the solid-state relay at the moment of the flash. Well, it's not there now. Yes, it's not. Well, since this module isn't working for us, it won't be. Okay, we turn everything off. Now let's see what exactly comes to this inverter control module. So, I continue examining this module. I have already desoldered this mysterious module from the inverter board. I took it out and connected it with wires, so that measurements could be made on it. So, I figured out that it should have the following signals. Counting from this side, the last pin is 0 volts. The pin before it is 12 volts. This is important so it receives power. Then the fourth pin is for enabling this module. So it starts generating frequency for the inverter transistors. Second pin. It receives a signal proportional to the energy we set on the display. Third pin. The third pin receives a signal proportional to the voltage on the capacitors. Fourth pin. This is the enable signal. I already mentioned it. And the sixth pin is a signal that allows the flash. But it's not relevant for us now, because it becomes active only when the capacitors are charged. So right now we're checking the power. Here I check. 12 volts is present. Good. Next, let's check. If the enable signal for the inverter module is arriving, this is the fourth pin. I connected to it. Now I turn it on. Yes, the lamp lights up. Now I start operation mode so that generation begins. It's on. 5 volts present. I turn off operation mode. Alright, voltage disappeared. So this signal is active. Next, does a signal come here from the control board? Proportional to the voltage we selected on the display? We turn it on. It's there. Now I adjust the voltage. Now it should increase. Yes, it did. Increased. Good. The signal is proportional to the voltage on the capacitors. Now it will be 0 because the capacitors are not charging. To check this capacitor voltage monitoring system, I will apply voltage from the power supply to the point where the capacitors are connected. And we'll see if there's a result on this pin. This voltage is converted through operational amplifiers. Yes. 1, 2, 3, 3 pins are 0. We see 0 now. Because I set the power supply to 0, I emphasize I am not applying it directly to this pin, but to the point where voltage is taken from the capacitors on the board. This is the point before the operational amplifiers and the whole signal processing circuit. Yes. Now I will increase the voltage on the power supply. We see on the oscilloscope that the voltage changes. Now I will decrease the voltage. It changes down to 12 volts. There's a limit because the system power is 12 volts, including the amplifiers and everything else. Yes, here I adjusted up and down. Good. I set the midpoint to 0. Everything adjusts well, works well. Except for this black box. So, the conclusion is that all conditions for this module to work are present, but it does not work. So the problem is in this module. Indeed, it is this module that's the issue. Of course, there is no documentation for this module. The only option, well, we could search for it, order it from China. But I still want to try to disassemble it and find out its internal structure. It's filled with compounds, probably epoxy. Well, I will probably make a second video and call it something like Black Box. So, what have we found out? All suspicion falls on this module. With this marking and unknown contents, power and all necessary signals were checked. The entire wiring was verified. According to this marking, it exists on the internet, but all links are outdated. So buying it is problematic. Though there's probably a way, we'll try to disassemble it and find out what's inside. And we'll do this in the next part of the video. For now, thanks for watching. Subscribe to the channel, and goodbye.